Hello busy bunnies. Today I want us to go through some circle measure questions. These I got from AdMath past papers for Cambridge 0606. And the first question reads, the diagram shows an isosceles triangle OBD in which OB is equals to OD and it's 18 centimeters. And angle BOD is 1.5 radians. An arc of the circle center O and radius 10 centimeters meets OB at A and OD at C. First part of the question says, find the area of the shaded region. So to find the area of the shaded region, all we need to do is find the area of the triangle and subtract it from the area of the sector. So the area of the triangle is a half AB sine theta, and the area of the sector is going to be a half r squared theta. So area of the triangle is going to be a half times 18 times 18, those are the sides of the triangle, and then times sine 1.5, and we're going to subtract that from a half r squared, our r squared, let me just erase that. So our r squared is 10 centimeters, that's the radius of the circle, squared times theta is 1.5. So that gives us, when we punch it in our calculator, as 1.161.594, and we need to subtract 75. That's what I got when I punched it in my calculator, and when I subtract that I get 86.594, which I'll give as 86.6 centimeters squared. The second bit asks, find the perimeter of a shaded region. Now to get the perimeter of the shaded region, you need to find AB plus BD plus CD plus AC. Now you'll notice that AB would be 18 centimeters minus 10 centimeters, which would give you 8 centimeters, and it's the same for CD because they're equal in length. Now we need to calculate BD. The simplest way to calculate BD would be to use the cosine rule, and I'm going to do it in one step. I'm going to square root, so it is B, which is 18 squared, plus C, 18 squared, minus 2, B, which is 18, C, which is 18, cos theta, our theta is 1.5. And when I punch all that in my calculator, make sure you put brackets here and here. That will give you the answer in one single step. And I got 24.539. Now AC is the arc length. You're required to know the formula for the arc length, which is r theta. Our radius is 10, our theta is 1.5, so when we multiply that we get 15. So we need to add 24.539, add to 8, add to 15, which gives me, let me just punch that out, 55.539, which just gives us 55.5. Great, that's the first question. Now we move to the second one. The second question reads, the diagram shows four straight lines AD, BC, AC, and BD. AC and BD intersect at O, such that angle AOB is pi over 6 radians. AB is an arc of a circle, center O, and radius 10 centimeters. And CD is an arc of a center O, of a circle, center O, radius 20 centimeters. Find the perimeter of ABCD. Now in this question, since I'm saying straight line, something that comes to mind is angles on a straight line add up to 180, but in terms of radians, angles on a straight line add up to pi. So the angle AOD is going to be pi minus pi over 6, which is going to give me 5 pi over 6. And because we have those straight lines AC and BD, we know that vertically opposite angles are equal. So this angle right here and this angle right here are both equal, and they're both going to be 5 pi over 6, and this is 5 pi over 6. This bit is going to be vertically opposite to our pi over 6. Something that I can see when I look at triangle ADO and BOC, that they both have equal sides, 10 centimeters and 10 centimeters, and 20 centimeters and 20 centimeters, and they also have the 5 pi over 6 angle equal on both triangles, making them congruent triangles, meaning that they're actually the same, only in different orientations. So when I'm doing those bits, I'm going to treat them as one, and then I'll just multiply by 2. But let's just work it out. So the first bit of our question is find the perimeter of ABCD. So we need to find AB. AB is going to be an arc length, and we're going to add that to BC. Just note that BC is going to be the same length as AD. So we'll just do one calculation and multiply it by 2. And then the last bit is going to be CD. I write it like this so that I don't forget that I need to add any things at the end of my question. So to calculate AB is an arc length, and what we're going to do is AB is equals to r theta, because that's how we find the arc length. Our r for AB is 10 centimeters, and then we're going to multiply that with our theta, which is pi over 6. So that's going to give me 10 pi over 6. Now I'll do BC. To get BC, I'm going to do one step just like in our previous question, and that's going to be the cosine rule. I'll do it in one step. So BC, I have one side as 10, so I'll do 10 squared. The other side is 20, so I'll do 20 squared minus 2 times the first side, which is 10, times the second side, which is 20, times cos 5 pi over 6. Now since I want to do it in one step in my calculator, I'm going to add brackets here and there. Now when I punch that out in my calculator, I get 29.093, and since there are two sides that are similar, that's AD and BC, I'm going to multiply that by 2 to give me 58 0.186. Now, to get the final side, which is CD, that's another arc length, so r theta, but the r for CD's bit is 20, and the theta is pi over 6, which gives me 20 pi over 6. Now, what I'll need to do is add all that together. So AB is equals to 10 pi over 6. BC and CB are going to be equal. So sorry, BC and AD are equal, and they gave me 58.186 when I multiply them by 2, and then I'm going to add the 20 pi over 6, and all that, when I punch it out in my calculator, gives me 73.894, which my final answer I'll give as 73.9 centimeters. Now, question B says find the area of ABCD. Again, triangle BOC and AOD are going to be equal, so I'll do one step for that. And AOB is a sector, so the formula for area of a sector is a half r squared theta. Sorry, that's theta. So I'm going to number this 1, I'm going to number this 2, I'm going to number this 3 and 4, so I can keep track of which one I've done and which one I've not done. So the first one, the area of 1 is going to be a half. R is 20, so 20 squared, and theta is pi over 6, so that gives me 400 pi over 12. Now, area for 2 is also a sector, and it's going to be a half. The r is 10 this time, 10 squared, and the the angle is pi over 6, and this gives me 100 pi over 12. And 3 and 4 I said are the same, so what I'm going to do is do 1 and then multiply it by 2. So 3 and 4, that's equals to 2 times a half AB sine theta. A is going to be 20, B is going to be 10, and then sine theta is 5 pi over 6. So when I punch that out in my calculator, I get 230.8997, which I'm going to give it as 231 3SF. So I punched out this bit, and this bit all in my calculator, and I got this as my final answer. We can move on to the next question. If you have any questions, just comment in the comment section. Let me know what problems you're having or if it's all clear. Now the next question says, in the diagram, PQ and RS are arcs of concentric circles, meaning circles that have the same center, with center O and angle POQ being equal to 1 radian. The radius of the largest circle is x centimeters and the radius of the smallest circle is y centimeters. Given that the perimeter of the shaded region is 20 centimeters, express y in terms of x. So the shaded region, we would get that if we minused, okay, so the perimeter of the shaded region, we need to add this bit, which would be x minus y. We need this bit, which would be the length of an arc, and then we need to add this bit, which would be x minus y again, and then this bit would be another arc length. So let's just sort that out. We'll start with QS, and QS is equals to PR because they are the same, and we'll find that that is just x minus y. And PQ, we said, is an arc length, which is r theta. In this case, our r is y and our theta is 1, which just gives us y. And the last bit, SR, is equals to r theta again, and our r in this case is x, our theta is 1, so x times 1 just gives us x. So let's write all that nicely. We've been told that when we add all that up, we're going to get 20 centimeters. So 20 is equals to, I'll start from the bottom here, x plus y plus 2x minus y, because we have two lengths that are equal. So that gives us 20 is equals to x plus y plus 2x minus y, minus 2y, sorry, which gives us 20 is equals to 3x minus y. And you've been asked to give your y in terms of x, so I'll just rewrite that and say y is equals to 3x minus 20. Great. So that's the first bit. The second bit is, given that the area of the shaded region is 16 centimeters squared, express y squared in terms of x squared. So the area of the shaded region is the larger sector minus the smaller sector. So let's just put that there. And the formula for area of a sector is a half r squared beta. So for the first one, it's going to be a half. I'll take the larger one first. The radius for the larger one is x, so x squared. Theta is 1, so I'll just leave it like that. And when I minus the smaller sector, it's going to be a half y squared times 1, so I'll leave that as well. And we've been told this is equals to 16. So next thing I want to do is multiply all through by 2, which is going to give me x squared minus y squared is equals to 32. And now you've been asked to give y squared in terms of x squared, so y squared is going to be equals to x squared minus 32, just by rearranging that. Now you've been asked to find the value of x and of y. You realize that you've come up with two simultaneous equations, that one and that one. So how I'm going to do that is I'm going to change this one so that it becomes y squared. So y squared is going to be equal to 3x minus 20 all squared. And when I open that out, I'm going to get 9x squared minus 2ab, which is 2 times 3 times negative 20. That gives me negative 120x. And lastly, 20 squared is going to give me 400. So I'm going to put this y, this is y now, y squared. I'm going to put that here so that I'll have 9x squared minus 120 plus 400 is equals to x squared minus 32. Now I'll move everything to one side so I have a quadratic equation that I can solve. And when I do that, I'm going to have it as 8x squared minus 120x plus 432 is equals to 0. Now when I look at that, I can see that I can divide everything by 8. So it's going to give me x squared minus 15x plus 54 is equals to 0. Now I'm going to use the factorization method to find this. I don't want to use the quadratic formula, although I could use it if I wanted to, but I can clearly see that if I multiply by 54, the two numbers I can multiply by 54 to give me negative 15 would be 9 and 6, and both would have to be negative. So this is going to factorize out to be x minus 9 and x minus 6. Feel free to use whatever method you find comfortable to factorize that. So my two x values would be x is equals to 9 and x is equals to 6. Now I'm going to find my y value from this equation. So y is equals to 3x minus 20, which is going to be 27 because our x is 9 minus 20, which gives us 7. Now if I do the same with this one, y is equals to 3x minus 20, I'll get 3 times x is going to give us 18 when our x is 6 minus 20, which gives us negative 2. And since you can't find a negative distance, negative length, this is not going to be a solution, so you'll write not a solution. And then this is going to be your answer, and your y is going to be 7. Okay, let's move on to the next question. The diagram shows a circle with center O and chord AB. The radius of the circle is 12 centimeters and angle AOB is 1.4 radians. Find the perimeter of the shaded region. Looking at this circle, I can see a major sector and a minor sector. We've been given the angle here. This angle is 1.4 radians, meaning we can find this angle. To find that angle, it's pretty simple. You need to remember that angles at a point add up to 360, but in radians, because this question is given in radians, you need to do angles at a point add up to 2 pi. So to find our angle, so major angle AOB is going to be equals to 2 pi minus 1.4. Let's punch that out and it gives us did you get 4.88? You get 4.883. Okay, so to find the perimeter of the shaded region, you need to do two things. You need to find the area of the major sector. So the area of the major sector is going to be a half r squared theta sorry, we need to find the perimeter, not the area. So let's just erase that. We are finding the perimeter. To get the perimeter, it's r theta. So perimeter of AB is going to be r theta, and it's going to be our r is 12 centimeters times our theta 4.883, and now that's going to give us 58.598. To get the length AB, we need to use the cosine rule. That's the simplest, easiest way, and it gives us in one step. So AB is going to be the square root, and let's use our cosine formula. Our first length is, let me put a bracket there, so 12 squared plus 12 squared minus 2 12 cos 1.4. Close bracket, punch it all out in your calculator, and you'll find that that gives us 15.416. So the perimeter of the shaded region, you add the major arc length to our AB, and that together is going to be 58.598 plus 15.416 gives us 74.014, which you can give as 74.0 centimeters. Now, you've been asked to find the area of the shaded region. Again, this is pretty simple. We're going to do the area of the major sector plus the area of the triangle. So the area of the major sector is going to be a half r squared theta, which is a half. Our r is 12, so 12 squared. Our theta is going to be 4.883, and the area of our triangle is a half AB sine theta. AB sine theta. Please remember that these formulas are not in your formula sheet, so you need to remember some of them by heart. So this is going to give us a half. A, B are both 12, so 12 squared sine. In this case, we're using the theta, which is 1.4, this bit. So sine 1.4. So when I punch those two out in my calculator and add them together, I get 22.5 centimeters squared. I think for this question, to make it easier for you to work it out, you need to remember that this angle, we can get it easily just by doing 2 pi minus what you've been given. Just like you would do 360 minus this angle if it was in degrees, but since you're in radians, make sure you always calculate radian questions in radians. Avoid trying to do degrees and then converting it into radians. So we have one more question to go. The diagram shows two concentric circles, center O, radii 4 and 6. The points A and B lie on the larger circle and the points C and D lie on the smaller circle, such that ODA and OCB are straight lines. Given that the area of the triangle is OCD is 7.5 centimeters squared, show that theta is equals to 1.215 radians to 3 decimal places. So the easiest thing we can do, because we've been told that the area of the triangle is 7.5, we'll use the formula for area of a triangle. So area of a triangle is half AB sine theta, and that's going to give us 7.5. So that's going to be a half. Our A and our B is both 4, so 4 squared sine theta is equals to 7.5. So I'll just rewrite that to give us 4 squared is 16. 16 divided by 2 is 8. So 8 sine theta. So I could divide this side by 8 and divide that side by 8, so that I'll find that sine theta is equals to 7.5 over 8. Then I can do theta is equals to sine inverse 7.5 over 8. Have this in brackets, and when you punch that out in your calculator, you get 1.215375. You need to have more decimal points than you're given in your question, 3 decimal points. So I just wrote that just to show clearly how I got my answer. And when I simplify that, I'm going to get 1.215 in 3 SF. Cool. Part 2. Find the perimeter of the shaded region. So the shaded region has AB. AB is an arc length. BC is simple, it's 2 centimeters, it's given, and it's equals also to AD, 2 centimeters as well. Now this bit is not an arc length, it's actually a straight line because it comes from this triangle. The one formula I want you to remember is the cosine rule. That's going to help us get this line. So I'm going to do it in one step. So first of all, I always like to write out which bits I'm going to get. I need to get AB, I need to get BC, I need to get CD, and I need to get AD. But we already know that AD is 2 centimeters. We know that BC is 2 centimeters. So the ones we need to work out are AB and CD. Let's work out AB first. So AB, we said, is an arc length. So r theta Our r is 6 centimeters. Our theta is 1.215 radians, which gives us 7.29. So this is going to be 7.29. And CD we said we're going to use the cosine rule. I hope by now you have mastered how to use one step to find that length. So you just write your square root sign because it would have been squared, isn't it? And then we find the sides. The sides are 4 centimeters, so 4 squared plus 4 squared minus 2 times 4 times 4 cos 1.215. Punch that all out in one step, gives you 4.567. So put that here, 4.567. Add all that together and you get 15.857, which gives us 15.9 centimeters. Okay, the last bit is the area of the shaded region. Now to get the area of the shaded region, we're first going to find the area of the sector AOB, and then we're going to minus the triangle DOC. So let's do that. So area of the sector is a half r squared theta, and we're going to minus the area of the triangle, a half AB sine theta. In this case, our A and our B are our radii, and then sine theta. So this is going to be a half. Our radius is 6, so 6 squared, and multiply that by 1.215, and then we're going to minus a half, 4 squared sine 1.215, and then we'll punch all that out in our calculator to give us 14.37, which just gives us 14.4 centimeters squared. That's the last question. I hope that was helpful. If you have any questions, just leave them in the comments below and I'll be sure to answer them. Have a nice day. Bye-bye.